Kia ora koutou, Reese from QuickSense here, and today we're looking at different types of graphs. Now this question's a little bit odd, but what it's asking us to do is grapple with this new form of a graph, right? Something that looks like this, ax to the n. What I know about the graph it's showing me though, is that it really is equal to -3. So what does that mean? Well, that means that whatever's going on in here, it has to, -3 times that has to equal -3. So what does that mean? Well, that means that x to the n must equal 1. Otherwise, -3 times whatever's not going to equal -3. So what value of n gives me this number, right? We're saying that for any value of x, and actually this is nice and easy, because there's only one way to do this, and that's if n is equal to 0. That's going to give me 1. So how can I write this in the form that it wants? Well, let's just move this up. It's going to be y equal to -3 x to the power of 0. Now in this next question, we're going to have to try and match the equation to the graphs down the bottom, or one of the graphs down the bottom. And we're going to firstly simplify, right, by changing a to 3b, and then use a little bit of substitution, knowing certain things about the graphs that we know to see whether they make sense. So firstly, what does it mean if a equals 3b? Well, that means that y is equal to okay. So what happens when x is equal to 0? Well, for this first graph, we can see that when x is 0, y is 0. So I'm just going to draw that on there. For the second one, when x is 0, y is -3. We've got -1 here, and we've got 0, 0 again. So if I'm getting 0, 0, or not getting 0, 0, I'm going to be able to immediately knock out two of these graphs. So what happens if x is 0? So if x is 0, y is equal to -3b. And what happens if b is 0, right? That's the only way we get y equal to 0. Well, then the rest of this graph doesn't make any sense, right? The rest of this graph is 3b, 0, right? 0 minus 0 is 0, right? This just doesn't make any sense. So what we're going to do instead is, well, first of all, we can knock out these two. That doesn't work, and that doesn't work. But we can see that -3b, so there's some b which makes -3 true, right? That would be 1. And there's some b which makes -1 true, which is 1/3. So that's what we're going to ask now, right? What does it look like if I substitute that b into my original equation? Well, so this is if b equals, let's go 1, what does the equation look like? And does it make sense? Right? So that makes sense. This graph here looks like this graph. That's possible. So what happens if b is equal to 1/3? Remember, in this situation here, we had y equal to -1 minus 3b. What's b? Well, it's got to be 1/3. So if that's true, then I get this equation. Now, what I'm left with here is this graph here. And what's the problem? Well, this equation, or this graph, is a cubic. This equation is not a cubic. So this one, unfortunately, that doesn't work, and that crosses out that one. So we were able to use substitution and some things that we know about graphs to narrow down to this graph here.